All right, welcome back to another video where I prepare for my new job. I believe it's going to start on the 27th because the 26th is a holiday, but all the paperwork, all that stuff is going through well behind the scenes. So let's keep studying network automation so that I'm as prepared as I can be. So in between videos, last video I was having some last video where I left off, I was pulling down a GitHub repo for Ansible. So it's kind of a large repo. I had to pull down a lot of information. So I decided to cut the video while it was downloading and not sit and wait for too long of a time. So between videos that had finished downloading, and I actually went through a few more pages in the book between videos and figured out how to use Ansible directly from the source code. And there's a big advantage in that because you can use any version you want really nice and easy when you do that. So I'm not sure what's happening with the Ubuntu server right now, so I'm just gonna exit GNS, reboot it. I've had it kind of sitting up for a while, so it hasn't been reopened in a while. So hopefully that's all there is to it. Of course, it's going to take a while for the Arista and the Juniper to come up, but the Ubuntu, the Cisco's will be ready to go. I'm kind of curious if the ViOS comes up right away or if it takes a while, just like the Juniper and the Arista. Yeah, I know the Juniper takes quite a while. I'm also working on the JNCIE SP, which is Juniper certification, and I have them set up so that they're just always on because it takes too long for them to boot up. And I know the Arista takes a while as well, but yeah, it looks like all of these take a while. In contrast to that, we can see the Cisco's are already up and ready to be used. That's because GNS3 is really optimized for Cisco devices, but it still works just fine for other devices, and it's really nice, I think, that they make it so easy for other devices to be compatible. And it looks like the ViOS switch came up really, really fast. Oops. All right, so let's kind of not worry about that for now. Open up the Ubuntu server. Hopefully so those issues went away. Just needed a reboot. Might not have even been up or something. So let's see if we can pull up a terminal and go through the things I did between the videos. So this is the command I issued in the last video where I decided to stop it because it was taking too long. We were pulling down this database with the -- recursive, so we were getting absolutely everything. There's going to be a chapter later, specifically on Git, which is a really important subject if you're working in a professional environment with code. Even if you're just doing your own stuff, if you've ever had a moment where you're like, oh, what did I do? I wish I could go back and see what I did. That's what Git is there. You'll never have those moments again if you know how to use Git properly and you actually do take advantage of it whenever you can. A really good thing you can do in Git, one thing I unfortunately haven't done yet, but it's a lot of really, really solid IT professionals do this, is they have their resumes in Git. So whenever they start a new job or something like that, it's all there ready to go. I'm going to pull up a IT professional that I actually went to college with right after high school. And I really don't stay in contact with this person. I haven't talked to him in a long time. I think I did send him a message like 5 years ago, but this, in my opinion, is a great example, kind of a mentor of somebody who's kind of doing everything right in in technology. And you can see he has a GitHub too. So let's see here. Yeah, and I believe he does have his resume up there. Yeah, he's got games. I think he does have his resume up there. I remember like I looked at it before. Yeah, repositories. There's like oh, here it is. Here it is. My latest resume. So you can see he's got a bunch of branches, or actually doesn't have any branches, but here we go. Updated resume, style sheets, index.html. Let's see if we can just straight up look at some of his past commits. So he's got 91 commits. And you can see he's keeping track of the changes he makes to his resume. So if he switches jobs, anything like that, he's got a running record of everything that he did. So let's take a look at, let's see if we can take a look at the first resume he had compared to the last resume. So this looks like just some testing here. But anyway, you can see just from this, you know, what a really like, you know, this guy, when I met him in college, you know, he was already, his father was an IT professional. He had learned a lot of things that IT professionals do and work with already. Just kind of, you know, for fun or in his spare time, he was using systems and software that would normally be reserved for IT professionals. So, and then graduated with a full computer science degree. Really a good example of somebody who is successful in this field. So I just wanted to show that as an example. I'm sure you could find a lot. Let's actually look up one more person. Let's look up Kenneth Reitz. So this is the guy who created the requests module. So, well, I mean, he created the request module, so I don't know if he needs a resume, but you can see he does, even though it looks like it's just kind of a joke. Assuming this is his actual archive, let's see if, okay, yeah, I think this is it, yeah, because he's got his requests up there. But you can, I think this does kind of drive my point home that a lot of really competent high-level professionals in this field will have their resume up on their GitHub. Unfortunately, I don't have mine up there, but I'll admit that I am in my, going into my 6th year of professional experience. And I graduated from networking school in 2015, which was my first introduction to a professional career in computers. Before that, I had different goals that I was pursuing. But you can see I do have a GitHub page. And I do have some projects I've been working on. Unfortunately, just with, you know, everything so crazy with COVID-19 and switching jobs, I really haven't had time to work on. This is the main one I'm working on now. This one's just kind of, I'd love to do some more work on this, but it's kind of just set up in a way so that there's really no need for me to develop it anymore. This one, it kind of needs a lot more work. But I do have a GitHub repo myself. And I will set up a new, you know, right here, right now. Why not? So it's going to be public, and it's going to be my resume. yeah, and then yeah, so then I'll kind of drive the point home here, and I will make a GitHub repo for the file where I have kept my resume. So we're going to use HTTPS for the link, and then we're going to go to where I keep my resume files, because right now I just keep them in my documents, and then in a job searching folder I've got here, and then I've got like a parent resume, so I've got JSON for it, and then I've got, whenever I apply to a specific job, I will go and make a specific resume for that job. At least that was the plan, but I haven't found a great program for converting. I used to use this website to convert my resume from JSON to a PDF for whatever format it needs to be. Here we go. So here's the main, and I've got a T-shooting file because I had problems with converting it. So yeah, this is, you can see what a big mess this is too. So this is the resume I've been handing out to people, and even this is missing my newest job title, let alone the one I'm going to start on the 26th. I mean, that one's of course not going beyond there until I actually start it, but I'm one full job title behind. So let's open a Git bash here, and let's demo a Git pull and a Git push. Or sorry, we're going to do a Git clone, paste. There we go. Yep, and it's going to be an empty repository. So let's move some files into it. So we'll move the JSON version, and we'll move the current version into it, and go in here, and then open a bash again. And then we'll do a git status. And yep, now we can see that these files are in this directory, but I haven't told Git yet, hey, I want these files to be a part of what you track. So let's do that, git add, and we'll just do a dot to track them all. It looks like there's some formatting that's going to need to change in the JSON. That's fine. So let's do another git status. And now we can see that they are going to be tracked, but I haven't committed the changes yet. The changes I made where I added these files to the repo. So let's do a git commit -m, and we'll just call it initial commit, just because this is the first commit, and then we'll select which files we want to include, and this dot means all files in the folder. There we go. So now we just need to do a git push up to the remote directory. So it's going to be, to check the git remote directory, it's going to get remote -v. So we can see we're pushing it up to my GitHub account. So let's push it. And then you can see this is abbreviated through a keyword, and that keyword is origin. It tells you that right there. So we're going to specify this URL, but we're going to do it through that keyword origin. And now we've got to choose which branch to push it up to. Let's just push it up to the master branch. And hopefully, yep. So I'm already signed in. I've got my, I think I uploaded my SSH key already. That's, I'm sure I did because I was working on those other projects. So if you're doing this for the first time and you're expecting to know how to do it fully just by watching this video, I got to be honest with you, you will run into a problem. The problem is resolved by going into the settings here, going down to SSH and GP keys, and then you've got to figure out how to do this. But hopefully there's some easy tutorials. Just Google for it. It shouldn't be too hard to set up. But I just wanted to make it clear that if you were trying to follow along with this and put your resume up to GitHub, there would be an extra step, because I had taken steps beforehand. Okay, so now my resume is up there. So I am now I think, doing what I would expect any other kind of seasoned professional to be doing, which is great. And I think that's a great thing I can do in this video, where I prepare for my newest job, is just to make sure I'm doing that sort of thing. So we've got that done, and we've demoed how to clone a repo from GitHub, how to create a new repo in GitHub. You can just use the browser for that, how to clone it down to my local files, and then how to add a local file up there. And again, you can just use the browser for that. There's a way to do it, but it can be a bit quicker if you use the command line for it. All right, and then this git bash, I installed a special software. Again, you can find online tutorials for how to do this if you're interested. But for now, I'm going to show off the things I did between videos now that this is good to go. So where I left off is this git clone. So let's do the next command. So we're going to cd to the Ansible directory that we got when we did the git clone. So if I do an ls-al pipe grep dot, let's just do a pipe grep dot git. You can see we've got these special Git folders, so that makes it a Git repository. So let's do source hacking env setup. So we're setting up Ansible to run out of checkout. And we already did this, so there might be issues. I mean, I already did this in between videos, but now we can see that we're running version 2.2.3.0. So if you want to switch versions, it's really easy. Now that you've downloaded the GitHub repo, you can just do git branch-a to check the versions that are available to you. They're going to be in branches. So you got to do git branch-a to see all the branches that are available to you. So we can also look at which branches are given which tags. So let's check out version 2.5.6. Okay, so we checked out the files. So now we can do source like so. And then now we'll see that we have a new version. We're running version 2.5.6 now, just like we specified. All right, so let's switch it back to the version they want us to use for the other examples. All right, so now we're running 2.2.3.0. So Git allows the maintainer to include other Git repositories called submodules in a repository as recommended by Ansible for running from source. Update the submodule to synchronize with the current release. So we updated Ansible itself to run at 2.2.3.0, but the submodules that Ansible itself will use have not been updated. So we want to bring them up to date to be compatible with the version of Ansible itself that we're using. Oops. So I need to actually list, okay. Oh, I've got to specify the submodule. We're going to update the core submodule. Okay. Okay, I think it's just already updated because I did do these steps between videos. So I am doing them for the second time. So I think it's good. Let's set up the lab for this Ansible exercise. So in this chapter and in chapter 5, the Python automation framework beyond basics, our lab will have an Ubuntu 18.04 control node machine with Ansible installed. This control machine will have reachability for the management network for our viral devices, which will consist of iOS V and NXOS V devices. We will also have separate Ubuntu virtual machine, have a separate Ubuntu virtual machine for our Playbook example when the target machine is a Linux host. Now we are ready to see our first Ansible playbook example. Your first Ansible playbook. Our first playbook will be used between the control node and a remote Ubuntu host. We will take the following steps. Make sure the control node can use key-based authorization, create an inventory file, create a playbook, execute, and test it. So I kind of want these steps. I'm gonna save this for when I go back because I want these steps. So the public key authorization, the first thing to do is copy your SSH public key from your control machine to the target machine. A full public key infrastructure tutorial is outside the scope of this book, but here is a quick walkthrough on the control node. Okay, so the control node. So this is going to be our control node. We already did this, so we're not going to be doing this again. But I will cat out the key that we've already got. There it is. So copy the content of the output and paste it into the authorized keys file on the target host for the same user. Create the file with a text editor such as vi or emac if the file does not exist. You can learn more about PKI there. Because we are using key-based authentication, we can turn off password-based authentication on the remote node and be more secure. We will now be able to use SSH to connect from the control node to the remote node using the private key without being prompted for a password. Can you automate the initial public key copying? It is possible, but highly dependent on your use case, regulation, and environment. It is comparable to the initial console setup for network gear to establish initial IP reachability. Do you automate this? Why or why not? So yeah, I guess I'm not sure what they're getting at. So let's try to do what they suggest here. And on the remote machine, so we're going to have another Linux Ubuntu server here. So let's just make sure that the authorized keys file on this has the public key from our control server. And if there isn't one, let's create it. Oops, it looks like okay, we got it. So open up a terminal and then we can do cd.ssh ls. Yeah, and we've got authorized keys. So let's cd into authorized keys. Oops, authorized keys is going to be a file. So let's cat out that file. So it looks like we've got a key ending in EDC7YHV. see what we got here. EDC7YHV. So we've already got the key up there, ready to go. So in the next section, let us take a look at how we can indicate the target machines to be managed by Ansible, the inventory file. We wouldn't need Ansible if we had no remote target to manage, right? Everything starts with the fact that we need to perform some task on a remote host. In Ansible, the way we specify the potential remote target is with an inventory file. We can have this inventory file as the etc Ansible hosts file, or use the -i option to specify the file during Playbook runtime. Personally, I prefer to have this file in the same directory as where my playbook is and use the -i option. Oops. Technically, this file can be named anything you like as long as it is in a valid format. However, the convention is to name this file hosts. You can potentially save yourself and your colleagues some headaches in the future by following this convention. The inventory file is a simple plain text ini -style. So that states your targets. Let's get some more information on ini quick. Okay. That's interesting. It's a Windows file, but it's not. Okay. By default, the target can either be a DNS FQDN or an IP address. So let's find this file. It's going to be in cd etc Ansible cat hosts. There we go. In this case, 192.168.2.122 is the IP address of a Linux machine that is reachable from the Ansible control host. We can now use the command line option to test Ansible and the hosts file. Okay, so we don't have, we'd have to specify. So let's look at that host file again. So here's all the things we have. Let's look at it with Vi or Vim, whichever one. Okay, so this is the default hosts file. So ungrouped host, specify before. Then we've got collection belonging to a group. We've got many with the same pattern. So let's just make ungrouped hosts. And oh, I thought there was a way in Vi to, okay. Oh, there is, but I'd have to look it up. I wish Vi had like I actually have a really good idea for a artificial intelligence project, and that would be to build an extension in Vi that will watch you use Vi, and then it will kind of keep track of like how long it took you, how many keystrokes it took you, and then it will give you back a printout of the shortcuts you could have used to accomplish the same thing you accomplished. And it will tell you how much time you would have saved, how many keystrokes you would have saved. I think that's a really great idea. And I don't know much about machine learning and stuff like that. I'm curious about it, and I've looked into it a little bit. But from the little bit I know, it really honestly seems like a kind of doable project. Like I don't think it would be, impossible. All right. So let's set the numbers, or set number, and then yep, so we're here. So I thought there was a way you could set which, okay, so let's go to Vim, oops, Vim, edit multiple lines. So yeah, or maybe have a Vim cheat sheet, just something to help. Linux Training Academy, that sounds good. There we go. So, oh, I don't see anything for multiple lines. Yeah, I'm just going to do it the slow way then. I apologize if anyone watching Vim, watching me right now is really good at Vim and is screaming at me. Please let me know in the comments how I can get better, what resources are out there. I know there's a pretty solid game that you can play that will make you better at this, but kind of want to work towards this video. There we go. Okay, so, well, we can just delete these. So we can say escape 3D, enter. There we go. And now we deleted all of those because they're not relevant. So let's add in the relevant IP addresses. So we'll just use what we got here. We've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 devices. So let me wire up this last one here. Oh, and we're out of plugs. So let's get rid of one of these Cisco devices. And then we'll plug the Ubuntu server in there instead. Okay, so it's going to be ENS3 on the Ubuntu server. So we're going to need to change the IP address on ENS3 so that it can connect up with the other Ubuntu server. So that's going to be, so it was ENS0 to ENS2, so it's going to be ENS5 because it's 3 more for some reason. So let's check what ENS5 was on here. Oops, and this is the wrong one. This is the one we're going to change, but we need to figure out what to change it to by checking ENS5. So ENS5. Perfect. So let's look at the IP address on this. 172.16.2.1. So we'll do 2.2 on the other side. All right, so we're good to go with that. So we can close this for now. Yep. And then just on the Ubuntu server itself here, we can figure out which IP addresses to include in this file, because they're going to be, I think, all just /30s. So we can do this, and then we can do inet pipe grep inet, pipe grep netmask. Okay, so now we've got all the IPs we're going to need to include. So I guess I'm not sure which would be the other side of this one here. I mean, we can always just try pinging the other side. So ping 192.168.1.12 maybe. Oh, actually, that's going to be my connection to my internal network there. So let's try pinging the rest of them though to make sure that they're good to go. Oops, so that one's not good to go. Okay, but that one's going to be good. This one. That one's not good. Okay, but we know which ones are going to be good, and we can just use those, maybe troubleshoot the other ones later. So this is the ones that are going to be good at 172.16.2.1. Let's do that. All right, and then the other one we got, I think we only had 3 of them. 10.10.10.1. Okay. 10.10.11.1. All right, and we'll just get started with those 3 hosts. I'm not even sure which ones they are. And then we'll move on from there. So I think in this step, all we're going to be doing is pinging those hosts. So we really don't need any information that is too sophisticated. So in this case is the IP address of the Linux machine that is reachable from the Ansible control host. We can now use the command line option to test Ansible and the hosts file. Let's do that. -I hosts. Oops. Missing target hosts. That's interesting. Oh, right, because we have to specify the hosts there. So let's just give it 10.10.10.2-m ping. So no host match. I think it was at .1. So, oops, it's unreachable. So I thought there was one reachable. Let's cat out that host again. Let's do a pipe less. There it is. Interesting. Okay, well, I don't know why it's trying to SSH, because we just want to ping it, but that is okay. Let's just see if we can get a different one. So let's see if we can get to 11.1. Nope, still a problem. Right, because we're using the wrong, I mean, if we were trying to SSH, we'd be using the wrong user account. All right, let's try 172.16.2.1. Okay, so now it's still unreachable even though we got the IP, but this is because it's trying to SSH into the host. So I don't know why it's trying to SSH when I'm telling it to ping with this -m. Let's keep moving forward. By default, Ansible assumes that the same user executing the playbook exists on the remote host. For example, I am executing the playbook as echow locally. The same user also exists on my remote host. If you want to execute as a different user, you can use the -u option when executing. That is -u remote user. This is the kind of thing that just drives me wild too, because if I'm telling it to ping and it's SSHing, it's doing something I did not intend it to do, which can be a huge problem. So I've always been a little bit skeptical of Ansible. I've always kind of been a fan of Paramiko and like having control over what happens on the network, because I'm just really paranoid that something's going to go wrong. And this is kind of affirming my confirmation bias against something like Ansible, because I told it to ping and it's trying to SSH. So what if I tell it to configure a port and it shuts the port down instead? Like, I want to be able to do my own safety checks beforehand and my own safety checks after. And if Ansible has some built-in stuff it does that I can't do that, you know, I don't know how safe it is to use. But from what I understand, it's used by a lot of people. At least that's what they say in books. That I haven't seen it used in a big capacity. But let's try to get the ping to work. So we're going to do -ping, and then we'll do -user. And I'm not sure which device this is. Is it the Juniper? So let's see which device this is, 172.16.2.1. All right, let's just try to go to the Cisco, actually. Okay, and the Cisco is at 172 or it's at 172.16.1.20, and it's username Cisco. No hosts matched, nothing to do. So yeah, we gotta edit up that host file with 172.16.1.20. Oh my God. All right, so we're all good to go now. let's try this again now that we've got that IP in our hosts file. Still, we've got unreachable equals true, and that's because it's trying to SSH even though we told it to ping. We didn't supply it with a password, so the permission is denied. I'm gonna pause it quick. I'll be back in a minute. I don't know what this is, why it popped up, but I will be back in a minute. All right, and I am back. So let's continue on with the book. I don't know what happened to where they thought that I could use the ping module and it would just ping instead of SSH, but obviously that is not the result I've got, but let's just continue on. The previous command line execution shown reads in the host file as the inventory file and executes the ping module on the host with the IP address 192.168.2.122. Ping is a trivial test module that connects to the remote host, verifies a usable Python installation, and returns the output Pong upon upon success. Oh, okay, so it looks like that ping module is only compatible with other servers. So you may look at the ever-expanding module list if you have any questions about the use of existing modules that were shipped with Ansible. So let's make sure that we're trying it on that server because it looks like that special ping module does use SSH, but it's designed to work with other Linux servers and not with networking equipment. I do believe that Ansible was originally intended to be used with Linux servers, and its use with networking equipment is kind of a later addition meant to make it more powerful. So let's find out what IP address this is. It is 172.16.2.2, so cat hosts. Oops. Pipeless. So we need 172.16.2.2 in this one. We've got the wrong one there. So there we go. There we go. All right. Okay, and now we've got the authorized keys file on this server filled up with the public key from this server. So we won't have those same issues with authentication because we have disabled authentication, I thought. So I don't know what shared, what? What does that mean? Oh, it didn't find. Oh, do I not have Python installed? Oh, I know I don't have Python 2 installed on here, and I think Ansible is meant to work with Python 2. So yeah. Yeah, so you can see I can ls and I've got that path here. But if I do that on this one, ls user bin Python, yeah, I don't have that directory in there because I don't have this same thing. So yeah, it's not going to pass the criteria for that. So I think that's okay. Let's just keep moving on. If the host's key is not found in the node's known hosts file, you will get a prompt. Enter yes to add the host. You can disable this by checking on etc Ansible, ansible.config. Okay, or home ansible.config. Okay, so ours is not going to be there. It's going to be at the first location with the following code. So let's do a back here and do a grep, and then we're going to do -a for we're going to get 5 lines afterwards, and then we're going to look for defaults. Let's get a help on grep. So yeah, it is -a. Okay, I think we've got to escape these characters because it's a regular expression. There we go. So now we matched on defaults here. Let's do another 5 lines. There we go. Let's get another 5 lines. Another 5. There we go. So let's see the host key checking. Oh, so we might need some more lines in order to see that. Let's just print out 40 lines, double that number. We'll do okay, yeah, here it is. Yeah, I don't see it, so I think you just have to add that line. Now that we have validated our inventory file and the Ansible package, we can make our first playbook. Our first playbook. Playbooks are Ansible's blueprint to describe what you would like to do to the hosts using modules. This is where we will be spending the majority of our time as operators when working with Ansible. If we use an analogy of building a treehouse with Ansible, the playbook will be your manual, the modules will be your tools, while the inventory will be the components that you will be working on when using the tools. The playbook is designed to be human readable and is in YAML format. We will look at the common syntax used in the Ansible architecture section. For now, our focus is to run an Ansible playbook to get the look and feel of Ansible. Originally, YAML was said to mean yet another markup language, but now has repurposed the acronym to be YAML ain't markup language. Let's look at this simple 6-line playbook. Okay. There's going to be 6 lines. First line looks like it has 3 dashes. Let's do a set number. And then okay, and then oops, hosts. It's going to equal, let's see here, Oh, it's going to be this host here. So so that's oh man, 172.16.2.2. All right, and then tasks, and then dash name, check disk usage, and then shell. In a playbook, there can be one or more plays. In this case, we have one play, lines 2 to 6. I mean, there's only 5 lines they gave us. 1, 2, 3, 4, 5. They gave us 5 lines. In any play, we can have one or more tasks. In our example play, we have just one task, lines 4 through 6. The name field specifies the purpose of the task in a human readable format, and the shell module was used. The module takes one argument of df. The shell module reads in the command in the argument and executes it on the remote host. In this case, we execute the df command to check the disk usage and copy the output to a file named df_temp.txt. We can execute the playbook via the following code. All right, so let's save this. We gotta specify the actual playbook. All right, so the host file was not found in hosts. Hosts list is empty. Lots and lots and lots of problems. This has typically been my experience with using Ansible. I have not found it to be something that has been useful. In my own experience, Paramiko, just bare Paramiko, I've had the most luck with. I mean, all the features you get through something like even NetMiko and stuff are assuming, you know, a lot about your environment, and you just use straight up Paramiko. You get to make those assumptions yourself. You don't have to rely on what somebody else believes your environment to be like. If you log into the managed host 192.168.2.122 in this example, you will see that the df_temp.txt file contains the output of the df command. Neat, huh? Well, if it works, it didn't work for us. You may have noticed that there were actually 2 tasks executed in our output, even though we only specified one task in the playbook. The setup module is automatically added by default. It is executed by Ansible to gather information about the remote hosts, which can be used later on in the playbook. For example, one of the facts that the setup module gathers is the host's operating system type. What is the purpose of gathering facts about the remote target? You can use this information as a conditional for additional tasks in the same playbook, which of course you can then do with bare Paramiko without that much extra code. For example, the playbook can contain additional tasks to install packages. By knowing the operating system type, Ansible can install packages with apt for Debian-based hosts and yum for Red Hat-based hosts. you are curious about the output of a setup module, you can find out what information Ansible gathers via $Ansible-I host-m setup. So let's try that. Okay, and you'll notice we had to be in the directory where the host file is, or specify a full path to it, most likely. But we can see because that device doesn't have the things on it that it thought it would, it is failing. Underneath the hood, there are actually a few things that have happened in relation to our simple task. When the playbook was executed, the control node copied the Python module to the remote host, executed the module, copied the module output to a temporary file, then captured the output and deleted the temporary file. For now, we can probably safely ignore these underlying details until we need them. It is important that we fully understand the simple process that we have just gone through, because we will be referring back to these elements later in this chapter. I purposely chose a server example to be presented here because this will make more sense as we dive into the networking modules when we need to deviate from them. Remember, we mentioned the Python interpreter is most likely not available on the network equipment we want to manage. Congratulations on executing your first Ansible playbook. We will look more into the Ansible architecture, but for now, let's take a look at why Ansible is a good fit for network management. Remember that Ansible modules are written in Python. That is one advantage for a Pythonic network engineer, right? The advantages of Ansible: there are many infrastructure automation frameworks besides Ansible, namely Chef, Puppet, and Salt Stack. Each framework offers its own unique features and models. There is no one right framework that fits all organizations. In this section, I would like to list some of the advantages of Ansible over other frameworks and why I think this is a good tool for network automation. I will list the advantages of Ansible without comparing them to other frameworks. Other frameworks might adopt some of the same philosophies or certain aspects of Ansible, but rarely do they contain all of the features that I will be mentioning. I believe it is the combination of all the following features and philosophy that makes Ansible ideal for network automation. Agentless. Unlike some of its peers, Ansible does not require a strict master-client model. No software or agent needs to be installed on the client that communicates back to the server. Outside of the Python interpreter, which many platforms have by default, there is no additional software needed. For network automation modules, instead of relying on remote host agents, Ansible uses SSH or API calls to push the required changes to the remote host. This further reduces the need for the Python interpreter. This is huge for network device management, as network vendors are typically reluctant to put third-party software on their platforms. SSH, on the other hand, already exists on the network equipment. This mentality has changed a bit over the last few years, but overall SSH is the common denominator for all network equipment, while configuration management agent support is not. As you will remember from Chapter 3, APIs and intent-driven networking, newer networking devices also provide an API layer, which can also be leveraged by Ansible. Because there is no agent on the remote host, Ansible uses a push model to push the changes to the device, as opposed to the pull model where the agent pulls the information from the master server. The push model, in my opinion, is more deterministic, as everything originates from the control machine. In a pull model, the timing of the pull might vary from client to client and therefore results in timing variance. Again, the importance of being agentless cannot be stressed enough when it comes to working with the existing network equipment. This is usually one of the major reasons network operators and vendors embrace Ansible, because it is agentless, but I forget what agentless means. It does not require a strict master-client model. No software or agent needs to be installed on the client that communicates back to the server. Oh, okay. That doesn't quite click with me, because if you were using something like those PyEZ, those PyEAPI, even just straight up NetMiko, that's agentless too. I mean, you don't have to install anything on the client. You have to enable SSH, yeah, but you have to enable SSH for Ansible too. So I don't know why they're saying that. I don't know what sort of system would be agent full. I know that yes, Ansible would have a huge advantage over any system that were agent full, but I just don't know of any system that is that way. And I wouldn't even know if it were, how you would install stuff on the remote side, like a Cisco router. How would you install client software on that to have it work? So this part, I'm very confused. I would like to see an example of an agent full software. I'm very, very skeptical about Ansible having an advantage over ad hoc Python automation, especially using a tool like Nornir or NetMiko, or even just plain old Paramiko, and just doing extra things to handle the outputs. Yes, item potency is really important. You've got to get back the same thing every time. But even item potency, I don't think is a huge deal, because you can just set up checks and say, oh, if I don't get back what I was expecting, shut her down, don't continue. So this is something I've heard a lot from like books like these and stuff. And I'd love it to click. I'd love to walk away from this book saying, you know, Ansible is the greatest thing ever, and tell everyone I love Ansible, but I'm just not there yet. I really don't see the big advantages it has over other tools like Nornir, NetMiko, PyEZ, EAPI. So let's keep reading. Idempotence. According to Wikipedia, idempotence is the property of certain operations in mathematics and computer science that can be applied multiple times without changing the result beyond the initial application. In more common terms, it means that running the same procedure over and over again does not change the system after the first time. Ansible aims to be idempotent, which is good for network operations that require a certain order of operations. The advantage of idempotence is best compared to the pexpect and paramiko scripts that we have written. Remember that these scripts were written to push out commands as if an engineer was sitting at the terminal. If you were to execute the script 10 times, the script will make changes 10 times. If we write the same task via the, well, assuming what, I mean, see, this is what gets me. Like if you were to execute the script 10 times, the script would make the changes 10 times. Maybe, maybe not. I mean, you wrote it. Did you write it to make, you can write in idempotency. It's not like you just don't have the ability to do that. Like with paramiko scripts, even pexpect scripts, but I would recommend paramiko, like you're at the terminal, like you choose the features that the script has and does not have. So you can write in idempotency. I don't think it's super hard to set it up to be idempotent. If we write the same task via the Ansible playbook, the existing device configuration will be checked first, and the playbook will only execute if the changes do not exist. I mean, look at it. Look, so let's read this again. So if we write the same task via the Ansible playbook, the existing configuration will be checked first. Well, why don't we put that in our paramiko script? We just have it pull show run, and we look and see if the change has already been made. If it has, then we back off. We don't do it anymore. Like, this is what gets me. Like, if you were to execute the script 10 times, the script would make changes 10 times. False statement. That's not a true statement. It's a dishonest, misleading statement. If you were to execute a script you wrote that did not have idempotency in it, yes, it would make the same changes 10 times. But why would you do that? Like, seriously, why would anyone do that? There's no reason for you to write out your own script that you sat down, thought about, and worked on, and not include idempotency. You can do that. It's not a matter of you not being able to do that. And they're seeming to, they're basically saying you can't put in idempotency. It's not something you can do. Absolutely untrue. You can grab a show run, you can read the show run, and you can put in a conditional to say, if this is not this way already, make it that way. And then you push out the thing, you run it 10 times. First time it does the show run. Oh, I don't see the configuration you wanted me to enter. Boom, it's in. Second time, does the show run again. Oh yeah, it's already there. Not gonna do anything else. That's idempotency, and that's easy using paramiko. You can do that. There's no reason you can't put that in. And this is what just drives me insane, like learning about Ansible and stuff. They make these ridiculous claims about what you can and can't do with just straight up Python code, and it's wrong. And not only is it wrong, using Ansible is more complicated than just, I mean, you can just, we saw in the scripts, I mean, let's see here. So let's go back to one of those scripts. But I guess I'll kind of make a long story short and just say that this statement here, if you were to execute the script 10 times, the script will make changes 10 times, is false. That's a false statement. It's completely misleading. It completely undersells what you can do with scripting. It's, I would say, half true, because yeah, if you wrote a script that did not check the configuration, did not have idempotency, it would not be idempotent, of course, but it's a false statement because it looks like it's assuming that you don't have the ability to add idempotency. But if you pull up a Python terminal, it's a Turing-complete language. You can do anything with it. That's the whole reason why people are so excited by programming, because it's Turing-complete. You can add anything you can think of. You can add to it. Idempotency is not something that is missing from Paramiko or pexpect. It's a part of it. It's just you have to implement it. And for me, that's a bonus because I know what I need done. Whereas a system like Ansible that's already created for specific situations that don't apply to me, I've got to essentially cut through all the weeds and get my way through the jungle through a bunch of stuff that just doesn't apply to me. If we write the same task via the Ansible playbook, the existing device configuration will be checked first, and the playbook will only execute if the changes do not exist. If we execute the playbook 10 times, the change will only be applied during the first run, with the next 9 runs suppressing the configuration change. And the thing that really gets about me is you'll be actually in the lab having finally figured this out, do it, and you'll find, oh, it doesn't actually do that unless I trigger some special switch or something. So not only are they misrepresenting what you can do with Paramiko, they're lying to you about how Ansible operates. So I mean, that's just, I'm sure it will be idempotent by default, but I would be really surprised if there weren't a way to undo idempotency, and if it were hidden behind the scenes and you could accidentally be running a Ansible playbook that is not idempotent, which would be a disaster. Being idempotent means we can repeatedly execute the playbook without worrying that there will be unnecessary changes made. This is important as we need to automatically check for state consistency without any extra overhead. Simple and extensible, and I might need to wrap it up soon. In fact, I'm going to wrap it up here. I need to take a walk, so I'm going to wrap it up here. Bookmark this, move my bookmark forward. And yeah, this section I think is really useful because as I've said multiple times, I'm a huge skeptic when it comes to things like Ansible, because it's just, to me, it feels like what you're doing is taking things away. You're saying, you know, where you could sit down at a terminal, spend a few hours and come up with this great feature. Well, now I'm going to take that away from you and you use this instead, and here's that feature now. It's like, you know, kind of like that meme. There's a great meme to explain this. So we have that at home meme. Yeah, this is the perfect meme. So it's like, let's see here. Yeah, so Mom, can we stop at McDonald's? So, you know, can I write in idempotency and use a Paramiko script? We have food at home, so in my Ansible scripts, well, here's my idempotency. You know, that's kind of how I feel about Ansible sometimes. Yeah. Can we buy AirPods? You know, can we use Paramiko, use NetMiko, Nornir, and type in and create some really great feature that's relevant to our network? You know, your boss or whoever, oh, well, we have Ansible, we have this platform, and then here's your platform. So that, I think that sums up really well how I think about that. I wish I thought differently. I'm trying to think differently. I mean, I'm reading this whole book and I'm seeing what the alternative is, what they're saying, but you know, I get hit with those examples like, oh, well, it's not going to be idempotent if you use Paramiko. And you know, I think anyone who actually has used Paramiko and is familiar with programming and network automation to a level that would allow them to successfully apply it in an effective manner will say, I can just write in idempotency. It's not that I don't have the capability of doing it. It's that it's not already done for me. But that's, in my opinion, a good thing because I can do it in the way it needs to be done and not rely on some existing configuration that may or may not, very likely is not relevant to my network. So that's kind of my 2 cents. So yeah, I've got a lot of confirmation bias, unfortunately. Kind of leads me to think Ansible is not the way. I wish I didn't have that. I wish I thought it was great. But I've had a lot of really, really good luck with Paramiko and just, trusting my own wits, my own experience on the network to guide me and have me know what's right. But yeah, I'd love to be a evangelist for something like Ansible, but that's why we're reading this book. So join me for the next video where we continue to read the advantages you can get by using something like Ansible over something like Nornir, NetMiko, pexpect, or Paramiko.